Recording.
Okay. There we go. I'm gonna share a screen. So my name's Bruno. I live in England, Sheffield. I'm an ex-architect. I've had a very varied career doing a lot of mobile structures. So I did a lot of large theatre tents, and more recently I've been doing large steel curved structures, sculptures, bridges, that kind of thing. But this is a project that I've had on the go for a while, which is Homemaker, which is a software for designing buildings using evolution and pattern languages. But what I'll do is I'll just explain what I'm going to try and do with this talk, and I'll try not to be too long. But so I'm going to first thing I'm going to do is I'm going to actually set up a job to do some evolution. It takes quite a while. In fact, normally it takes like a day or a week to design a house. But I'll see what happens after I've done the talk. See what happens, after 20 minutes. See what we get. Then I'm going to talk a bit about pattern languages, because pattern languages are quite central to this project. And then I'm going to do some explanation of the geometrical model that allows you to have houses that can be designed by computer, and how the evolution crossover works. Then I'll show you some models in Blender, and then there's a daylight model which might be of interest, may not be of interest, that I use. And then hopefully at that point, the model that I've just about to start off will be finished. We're going to have a look at that. So maybe it won't take too long. Now I've just I realized that my Linux laptop wasn't going to be able to cope with doing video as well as doing examples. So I've switched to a Windows machine here, which may or may not work, but we'll find out. So can everyone see my anyone see my terminal shell here?
Yep.
Yeah. Okay. So there's a So in this is a folder, and it's got well, it's got two files, but ignore the make file. It's got this file called a DOM file, which is a just a small text file that describes a building. It's basically the data format that I use. So I'm going to open up this file, and you can see that now I do have a tool for generating. So this is the file that just describes a building plot that we're going to put a building into. Now I do have a tool that generates this from Blender, but Blender 2.8 changed they broke the DXF file export, so that no longer works. So at the moment you have to you just have to create this file by hand. And it's a simple file. It just has 4 coordinates for the corners of the plot in meters. It tells you which edges are private, which is like a party wall, and which is a street. And then all the rest of the information. Elevation is just height. And basically, you could write this file with the node list with the 4 coordinates, and that would be fine. So what I'm going to do is I'm going to run the tool which runs the evolution tool called herbevolve, that will load this file, and it will create a population of I think 128 copies of this file, and it will then start mutating them and doing crossover and mixing them around, and at each level, each generation, it will be running a fitness calculation, and then it will be discarding the least fit members of the population and duplicating the more fit members of the population. And so what you end up with is a whole load of different versions of the same building that have they're all slightly different designs, and some of which have high scores and some of which have low scores. So I'll so if I start that off now, so straight away it's telling me that it's got it's got no bedroom, it's got no kitchen. The plot ratio, which is the floor area ratio (FAR), is no good. And this is just reporting on the best of the population. what I'll do is I'll create a couple more. Sorry, wrong folder. So I'm running on using two processes at the minute. So I'll do another one. I'll do because it's an evolution process. It will tend to dig holes. It always finds a local minima. So quite often the result isn't as good as it could be, and it stops. So I will try and do 3 different models and see which one's the best. So let's leave that running. So let's have a look. I've got a slideshow here. Okay, so let's can you see that? There's an image of some houses.
Yep. Yes.
Yep. So this is a slideshow. So what I'm trying to explain what I'm trying to do. I'm trying to generate what we call this compact city model, because most of the ways we have of designing buildings are all about designing at a large scale. So and the way we've done that, and the way it's been happening for the last 100 years or so, is that we duplicate everything. We design one house and we copy it 100 times or 1,000 times. Now, there are various drawbacks of that approach. Is you end up with tower blocks, or you end up with these rectangular buildings that don't fit together very well, and it ends up in a very low density or sprawling model, city model. So the other alternative again is to create a whole load of flats or that are all identical and duplicate them again and again and again. And I don't see either of these urban models as being particularly great. So what I would like to see, and this is the kind of urban model that I like, is 2 or 3 story, 4 story maybe urbanism, narrow streets, houses packed tightly together. And this is what I'm trying to create. I won't try and explain why I think that's a target to go for, but this is where I'm at. So this is a house model. This is very similar to the model that I just started off running in the background. Now, the way that I've discovered that I can model a house is to do everything as quads, as 4-sided shapes. So you notice that this isn't right angled. It's nearly a rectangle. Now the way to do that I then model it is with this binary tree. So you can take any 4-sided shape and divide it into 2 more 4-sided shapes, and these become the structure of the house and the rooms of the house. So we've divided that into 2, and you can see the binary tree on the right hand side. And I've divided one of the sides then into 2 again, and you can see the binary tree is extended at the bottom to match. Now so the data model inside that DOM file that I showed you becomes this. It represents the binary tree. It doesn't represent the model on the left. The model on the left is reconstructed from the binary tree, and you'll see why I use the binary tree in a bit. So then that side's been split in half again, and we're starting to look like a house plan. And divided again. So what can we do with this model? We can I can then take this binary tree and produce a network graph of walls. So each of these segments here in this network graph are wall segments with nodes between them, and then the dual of that graph, which I don't know if you know about graph theory, but the dual is the DUAL is like the inverse graph, and that inverse graph represents the connections between rooms. So we can use these connections between rooms to evaluate the house. So if each of these rectangles are rooms, then we know which rooms can be next to each other and which rooms aren't. So and then if we label, and what I'm doing is I'm just assigning room uses to each of these nodes. Some of them are outside, some of them are living rooms. I'm using a very standard domestic model where we have living rooms, kitchens, bathrooms, circulation, toilets, things like that. And so from that binary tree on the right, we can determine a full house plan, or you, based on certain assumptions, any binary tree that you draw on in the data model can be converted into a geometrical model of a house, and this extends upwards into multiple floors as well. So just trying to explain that that actually this has some precedent. So this is a house. This house is North African from more than 2,000 years ago, and you can do the same process. You can draw a rectangle for the outside. You can start subdividing it into more rectangles, and you can carry on subdividing it. Yeah, and this is a process that basically works for all load-bearing wall construction. It doesn't work for various other buildings. It doesn't work for circular huts, for example. It doesn't work for very formal classical buildings at all. It doesn't work for a lot of Japanese traditional architecture, because that's post and beams, not load-bearing wall. So here's another example. This is a famous Victorian building in Britain. Now this can be subdivided in like so. A couple more steps. So this has got a lot of levels of subdivision. So I'll go back to that. So I know that looks a bit weird, but now once we've done this subdivision, I can actually represent that house. I can say which rooms are next to it, which other rooms, how big they are, how much daylight they've got, how the circulation works. So let's go back to that model I had before. I can then I can do mutation on the model. So by manipulating the data in the binary tree on the right hand side, it determines a different house layout on the left hand side. So here we go. So that was a mutation that swapped or actually rotated one of the nodes around, so that the rooms went from being there to being there. Here's another mutation that subdivided a room, so turned one room into two more rooms. So once we've got multiple models that are different, we can take two house models, and we can do what's called crossover or recombination, which is a process that happens in genetics, but it also happens in evolutionary computing. So we can take a chunk out of the left-hand side binary tree and a chunk out of the right-hand side binary tree marked with the red arrow, and swap them over. Yeah, and what that does is that creates a new binary tree with a whole new house layout. And so this process of recombination is much more effective than just pure mutation. Pure mutation tends to end up with very simplistic houses. And originally, when I originally started programming this, I just had a mutation operator, and it always ended up drawing basically the same bungalow every time. And it wasn't until I started the recombination crossover process that more sophisticated houses came out of the evolutionary process. This is where are we at? No, I'll show you some 3D models. So how do I share that there? Yeah. So here's a model. Some of you might have seen this model before on the web. Can everyone see that? I hope everyone can see that and still hear me. So this is
Yes.
so I've gone through the process. I've been mutated all these buildings. There's 19 buildings here, and they've been mutated all at the same time and evolved all at the same time. And what they have is, and we have a daylight model so they're growing in the shadow of each other. So they tend so the idea is that if one building's in the way of sunlight, then it will be putting outdoor areas in another building in a different place, and hopefully they grow together into a composition. So this has been converted in from. So what I've done here is I've generated an IFC file and imported it using Dion's Blender BIM IFC importer. And as you can see, this is up at the top left. You can see it's a wall, IFC wall, and we have the entire structure of building. So each there's 19 plots, and there's one building per plot, and we have the whole structure of building stories. Yeah. See if I can select the building. Yeah, so there we go. So if we select the building on plot 1, yeah, it appears here, and it's got no roof. Which is a bug. It's either my bug or Dion's bug. I'm not sure which. But there's quite a high level of IFC information in here. So if you click on that window, you can see that it's a bedroom window. Yeah. That's not the bedroom window. These are all bedroom windows. That's a toilet window, and inside there are. Let's open up this building here. So if we take the roof off it, there's I hope you can all see in there. So there's it's got a staircase. It's got an entrance on the street. We have so there's the entrance here, and this is the bedroom here. It's got a large bedroom. Then yeah, it's a very small bedroom. And of course these are all what do we call them? They're IFC. They're not IFC products. They're shared. So that window has been reused a whole load of times in different buildings. But as you can see, there are different size windows because some of the buildings have higher floor levels and some of them have lower floor level ceiling levels. So this is a smaller window that appears in other places in different models, depending on the ceiling heights of different stories of buildings. I don't know if there's anything else to say there. I mean, I'm certainly targeting IFC now as the final result. Before I was creating a DXF file and a Collada file, which works quite well for visualization, but I think the IFC output has much more potential. Let's show another model. Yeah. So this is a smaller model, and this is a bit more. This is a bit more of a tight urban form. The other one was a bit more, a bit looser. With very large buildings on large plots with relatively large backyards. This one's very tight. All these building plots here are less than 100 square meters, 60 square meters, 70 square meters, and so this has managed to fit 1, 2, 3, 4, 5, 6, 8 small buildings on a 1/16 of a hectare, and these are two or three bedroom houses, so they're not that small, but there's I don't know what's 8 times 16. It's quite a lot of houses per hectare. And this is basically what I'm targeting. This kind of compact city form. Don't know what there is to see in here. So this house is quite small. It's basically just a stair core, and there's a what's that? Yeah, it's a bedroom there. There's a nice little balcony, and then downstairs there's a toilet and living room. Yeah, living room and the stair core. So it's quite tight. It's quite a small house actually with one bedroom. I can let's see. Now these are obviously all styled with the same look and feel, which was basically this was the house that I was living in at the time. So I went out and I measured all the windows and doors, and the roof, and I copied the style. So there's none of my creativity in here at all. So if I share this model here, so this is I'm using exactly the same process, but with a lot of parameters changed. There are so what this model is designed for like a desert climate. So what I've allowed is for circulation through courtyard areas, and that ends up immediately with a very different urban form that you end up with because you have circulation in outdoor areas. You have to have a wall separating you from the street, and let's have a look, see if there's anything inside one of these. Yeah, so there's some rooms here.
Bruno, sorry for jumping in. Would you like to try the section plane tool? See if you can cut a section through.
Yes, it's been crashing on me, but I will try it.
Okay, then better not try it.
Let's try the section plane. Okay, so watch this. Add temporary section cut. Oh no, it worked. Great.
Okay.
No, thanks. I wasn't going to do it because it was crashing on me. So so what we have here is we have some staircases. So here's a house. You're going through the front door. There's the stair going up. There's a little courtyard. There's two little rooms, bedrooms, kitchens. I don't know what they are. And then as we go up, there's the next floor up, the first floor. Stairs carry on up, and there's a bit more circulation on roof spaces. So you have these rooms where these buildings where you can go up the stair here. So there's an entrance on the street here. Sorry, an entrance on the street there. You walk into a courtyard. There's a staircase at the back. Staircase goes up onto the roof, and then on the roof there's one room here with that's a bedroom. These are, I mean, I won't say they're typical North African style houses, but they're very similar in some ways. I haven't spent much time on this, and of course, different desert climates have different architecture, of course.
Sorry, just jumping in. Maybe Cyril doesn't have a mic. Cyril sent a message in the chat saying, "Designed for areas with warm climates," with a question mark.
Yeah. So I have a daylight model with that knows where you are in terms of latitude. So the Northern European houses tend to have daylight coming in from the sides, whereas the daylight on one of these buildings is mostly coming from the east and west and from directly above. But mainly what's going on in this model is that the style's different, and that I have a different circulation model that allows circulation through outdoor spaces, which seems to be the main determinant. The main difference between a European house and a desert house is that you have this circulation through outdoor areas. I mean, I haven't finished it. There's a whole load of things that need layering in, but quite often you have two kitchens, or you have what's called a dirty kitchen, which is basically an outdoor kitchen because you can't cook indoors in these kind of climates. There's a bug there. I think that might be a, I don't know where that bug is. That could be in Blender BIM, or it could be my bug. That should be a parapet, but it's missed a node. So all these components here are, oops. So these are all it's a window. These are extrusions that follow parapets or follow eaves. This is an extrusion. Have some nice little windows there, and try and walk down the alleyway here. Anyway, this is a model. I've explored it. I got it working, and then I kind of abandoned this one. Haven't done much more on it since. These are these red marks. These are glitches because the flat roof is a very thin wedge, and the import has the import from RFC OpenShell comes in triangulated, and Blender BIM is merging triangles into quads, and it's got that one slightly wrong. But it's not a big deal, obviously. So I have this this building model which I've shown. We have an evolutionary, and I have a good way of evolving those models. But the other part of this is you need a fitness criteria for models. So which is basically saying this building works and this building doesn't. And what I'm using for this is this book called Pattern Language. I won't hold it up because you're looking at the screen. I'll show you. I'll show you the ebook of the book. Let's have a look. Let's go back to there. So this is in fact I won't. I'll show you the actual book. Okay, I don't know how to unshare, but I'll if you can see my picture there, I'm holding up a book. I mean, if I'm in my thumbnail.
Yep.
So this is a book written by a guy called Christopher Alexander in 1977, and it's and if you look, it's a list of 253 patterns, which and it's 1,200 pages. It's a big book. It's quite expensive, and each one of these patterns describes a particular problem that you encounter when designing a building, and it gives you a solution to it. So it's quite a they're very specific. You know, they say you need a sunny space and in your house, and this is how you do it. But what it doesn't tell you is it doesn't tell you how to design buildings. So this I don't know how many have heard of this book, but this is quite a long way, by a long way, the best-selling architecture book that's ever been published. But no architects use it. It's almost completely ignored by architects. And I feel that's the reason for that is that largely because there's no design method that comes with the book. It tells you what's great about a great building, but it doesn't tell you anything else. Yeah, it doesn't tell you how to do it. So there's a whole load of what they call patterns, things that are good about good buildings. But I should try and get as many of these as possible. So my fitness calculation doesn't implement all 253 of these patterns, but it implements good 30 or 40 of them. So I'll spin through the. So each of these patterns has a statement of the problem, and then it has some discussion of the problem, and then it states the solution. So the solution is, so for this pattern, it's telling you to build porches. and this pattern here is called 6-foot balcony, and the crux of this this pattern is basically that any balcony that's smaller than 6 foot, 2 meters, basically never gets used. So I have a part of my fitness calculation checks all the balconies and makes sure that they're at least 6 foot, and houses with balconies smaller than that fail. So there's nothing in the evolution process that will stop a building from having a 1 foot deep balcony, except that the fitness function will tend to discard those buildings. So let's see what else can I talk about. There's if I go back to the slideshow. So I have a daylight model. So this is a bit more technical, this bit. I might skip through it quite fast. So for in order to calculate the daylight for any particular window or outdoor space in one of these models, I can't do a full ray tracing of the entire scene, because I need to do dozens, tens, maybe hundreds of fitness calculations every second. Well, maybe thousands of fitness calculations every second. And so the shortcut that I've developed, which is I draw a grid on each of these plots, a 1 meter grid that's horizontal and vertical. And for each of those points, I draw the profile of the horizon. So this is like a horizon mask that includes surrounding buildings. So I can mask, so I can determine that in every direction, each of these 16 directions, how much sky there is. And then I can, and then that's cached in a database of. So every point has these 16 directions, which says where the horizon is, and from that you can work out exactly how many hours of daylight you get from every direction, and you can add it up. So I can very, very quickly for any outdoor space say exactly how many hours of sunlight that spot gets per year. And similarly for vertical surfaces, I do what's called a CIE sky. I don't know what CIE stands for. It's some standard organization, and they have a model of overcast skies that you can use. So I know which rooms are getting light and which rooms aren't getting daylight, and all that gets fed into the fitness calculation. And so while you're evolving a house, obviously the walls are moving around. So I can generate an overlay mask for each of these walls in the current house that's being designed, and dynamically change the mask. So it's a very, very fast way of calculating daylight, which I needed because this is all written in Perl.
Sorry, Bruno.
Yes,
are you making a presentation now? Because we see your camera. I don't know if you.
Oh, right. Okay. Right. Well, sorry.
Okay.
Oh yes. I see. Yeah. Okay.
You forgot to.
I did. I went to switch it, and then I couldn't figure out how to, and then I obviously did. Yeah, this one here. Sorry. Yes. So here's the scene. Sorry, I'll quickly go over that. So this is the scene. This is the horizon mask, calculated by looking at all the walls in the scene. And then I split the scene up into 16 directions, and from that I calculate. So then I store simply a height of the horizon in all 16 directions for every point in the plot, effectively. And from this I can calculate the net hours of daylight and the amount of overcast daylight you get in a window. So sorry about that. And that's the final slide, and you can see then that's an overlay mask. They're all supposed to represent it. So this is just a quick demonstration. So this is these are vertical slices at 1 meter intervals through in the plot. The plot doesn't have a building in it, so this is the amount of sunlight hours, the direct sunlight hours that you get for every point in this plot at every height interval. Okay, I'll just quickly. I'm near the end now, so you're okay. So it's all written Perl, which is a very unlikely language, but it's kind of the only language that that I'm any good at. So so I wrote it in Perl. There are 5 Perl modules on the that you can download. But the actual main one is this herb Perl module, and this is the data model, and this contains all the evolution and the fitness model and a mutation model and crossover modules. And that's what I'm running in the background here with trying to generate these 3 houses. And then I have these 3 modules that I use for output. So I have this Molior module, which is Latin for I can't remember what actually. So this generates the 3D geometry. And then I have 2 other modules that just create DXF files and IFC files. The DXF path is I'm going to abandon it at some point, but for the time being, I'm loading resources like windows and doors are stored as DXF files, and then I convert them to IFC and merge them into the IFC file. But then surrounding all this, I have this Homemaker module, which is a queue manager. And so what this can, because there's quite a lot of processing involved, and if you're designing lots of buildings, it gets very complicated very quickly. So I have this module that can manage multiple processes, and it'll dispatch jobs to different worker processes. Now these worker processes don't have to be on the same machine as long as they share a file system. So this scales. Potentially it can take it's even though it's very slow designing a single building, it's not actually that much slower to design 100 buildings at the same time on the same site. As long as you have enough processes, you have to have 100 processes. Okay, that's the end of the slideshow. I'm going to go back to one of these blenders. I'm going to switch desktop. Tell me if it doesn't work. So here's the Blender model. In fact, no, I need to go back to the. Sorry, I'm going to switch to the evolution process. So here's one model. If you can see my terminal there. So,
yes.
So this house is this is one of the 3 houses that I set up running. It's designed 128 meters squared house with 3 floors. The first floor, which is the floor above the ground floor, has no outside balcony, so that's not too bad. Let's have a look, and the score is 0.0014. So a good score would be 0.1. So this is really not. I could expect this house to be 100 times better if I ran it for a day or 2. So here's another one. This one doesn't have any errors at all, which looks good. This is a score of 0.035. Again, it's on 3 floors. And that one's on 3 floors. This also doesn't have any errors, but I'll take the best one. So all I'm going to do here is I'm going to Control-C it. That kills the process, but it forces it to write the file. So now I have this file, and this is a hash of the contents. So this is a new file, and you can see that even though I have this this node structure, this plot structure on the for the 4 corners is still the same. I have this this binary tree here that's being built of how it's been divided up into rooms. So I have left and right. If it's divided, there is left room and a right room. Some of them are. So this is that's an outdoor room. This is a kitchen with K, and then we can keep going down here. So as it indents more, it's actually going upstairs. So this is the next floor up. Has a toilet, has an outdoor, has a bedroom, has a circulation. This is the top floor. Has 2 outdoor spaces, a circulation space, and a bedroom space. So let's generate a 3D model of that. that was. So this is reading that file. It's creating this file format, which is like an API file format, which is almost like a BIM format called Molior. But then from that, it's generating, that little script has just generated a DXF file, and a Collada file, and an IFC file. If I switch to, so I'll go back to Blender, and I'm going to import the IFC file. So that was here, that one. No, I'm not using native representations because sometimes that doesn't work. So here's the building that's just designed. So this is what I set off 40 minutes ago. Blimey, I need to wind up. So it has a covered area. There's a gap above the column here, which isn't good. That's a bug. There's a front door. If I remove the front wall, you can see that there's a stair core there, and I could be daring, and I'll try and use the section plane. Right. So we've got downstairs. There's that's a kitchen with a street window. It's got a living room there. There's a nice pair of double doors between the kitchen and the living room. There's a door from the living room into the stairs, but not into the kitchen. It's decided that wasn't worth doing, or it wasn't necessary. So let's go up. Let's go upstairs. So this is the what we call the first floor, or the second floor if you're in America. So here's this is a toilet off the stairs. There's not enough light in here, is there? Add. Okay, still not enough light.
In the world settings, you can change it to white.
What, change the light?
In the world tab on the bottom right.
Yeah. That one. No.
No. Up.
No, that one.
Correct. Change that color to white.
Yeah, that one there. Yeah. Okay. Still no shadows there. But yeah. I could turn on cycles, but that's a bit slow. So up here there's there's a nice spiral stair. There's a door from there into the bathroom from the stair. There's a door to, I'll assume, is a bedroom. Yeah, so there's a bedroom here. The bedroom has a balcony. And then let's go up another level. So onto the second floor. There's basically we've got another bedroom. Yeah, it's a bedroom, and there's a balcony, but the balcony is accessed from the stair. So this is the balconies are one of Alexander's patterns. So you'll see in these models that there are an awful lot of these balconies with pergolas, but it's basically because I'm very strictly implementing the pattern language that's why they appear everywhere. But it's tunable. So if you want to edit the config file, which you can have a separate configuration file per building or per project, you can change all that stuff if you want to design different buildings. So there we go. That's a house. I can turn on cycles. There we go. I think that's where I'm done. I'll try not to overrun the time because obviously there's other thing to do. But has anyone got any questions?
Yeah, I've got one.
Yeah.
Does it generate spaces without a wall between them? Because nowadays you have very common open plan kitchen, living room, dining room.
Yeah, you could do. It's basically it's a very traditional layout that I've used, and but the engine itself isn't limited to this. So what I've done here is, as a special case, is put it's drawn a kitchen area and a living room area, but it's put double doors in between the two. Now you could tell it to not draw a wall there at all. Yeah, you know, it could just as easily create an open plan ground floor, like so.
I've also shared a link in the chat. There was a paper done about 10 years ago. It was in SIGGRAPH about generating a residential layout very, very similar to yours, with one difference.
Yeah, sure.
I think for their approach.
Yes, I've seen this.
They do the walls, not the rooms. They split walls instead, like almost like the inverse.
Yeah, I to be honest, I don't know how I don't know how they ever got that to work. I've tried all sorts of different ways of doing this, and the advantage of my approach is that whatever binary tree you create, it always generates a building. Yeah, and that building always has rectangular rooms, and you can always calculate whether those rooms have a circulation model. Whereas this paper, they just wiggled the walls around the space. They never took it any further than this. So I quite wonder. I wonder quite how much it was working and how much it wasn't. So yeah, this this was 2010. Yeah, so I mean I'd already been doing this for a couple of years at that point, but there doesn't seem to have been much research in this area. There's been people designing large sites, placing office buildings and trying to maximize floor area and so on. Or WeWork had a whole load of programmers, like hundreds of programmers, writing algorithms for laying out tables in office spaces, and some very similar things like that. But as far as I can tell, there's nobody else really working on this kind of thing.
I think there's TestFit doing a lot of that. Have you heard of them?
Yeah.
And ArchiStar?
No, but they're doing they're placing buildings on sites, aren't they? Rather than designing building layouts. I hope. I assume.
I think ArchiStar does buildings on sites, but TestFit, I think, could be wrong. They do rooms.
No. Right. Yeah. Sure. It's been a strange journey, this, because I started off, I wanted designing buildings, and I realized that there was a way of getting Alexander's language to work, but I could only get it to work with this traditional model, these very traditional building layouts, and whatever I did, that's the only way that if you want a building to evolve, it has to be like that. That's the conclusion I came to. But I don't know, I'll definitely have a look at TestFit. Yeah.
Can I ask something? The windows, for example, that I see that they are aligned, for example, in this view, is this some kind of, let's say, it is embedded in the code that it is better to be aligned, or?
Yeah, it's the answer is that no, but because the rooms above and below are similar, I mean they can be subdivided further. But if the windows, well, okay, so I have a database of windows, and each window type, I tell it how much space that it's allowed between that window and the next window, and how much space I'll allow it between the window and an internal wall or an external wall. And what it does is it tries to place them. So even though there's so if you look at this elevation here, even though there's a room here with two windows and a room with one window, it's very likely to equally space them across the facade. Now, if one of these rooms gets quite small, or there's an entrance door downstairs, then it'll shift it along and they won't line up, which is a very typical traditional way of dealing with these kind of issues. It turned out that it was much easier than I expected.
Okay, thanks.
Stephen has posted in the chat a question. Is it possible to handle terrain with heavy slope?
Yes, basically. So the model that I deleted to open this one, I could import it again, which is this one here. This will take a while to open. I know I've opened it in the same file. Let's see if that works. Yeah, there won't be a Python port. Sorry. If I'd have realized how much work it was going to be and how long I'd be doing it for, I would have taken the time to learn Python and written it in Python instead of in Perl. Though it's quite possible that because it's lots of different modules that communicated through text files, it could be ported to different languages bit by bit. So it's not such a bad situation because there are not many people who understand Perl these days. I'm just going to kill these other evolutions that are running in the background because they're because the fans have kicked in.
May I ask you a question? When you talk about the pattern language, you say that you integrated almost less or more 40 different patterns. But can you make an example of a pattern that you integrated and how the tool deal with it?
Okay, so so I mean, one of the main patterns that determine form, it turns out to be this light on two sides pattern. So the way it's presented in the book is that all rooms should have double aspect. They should have windows on more than one wall. But the pattern's a bit more subtle than that. It says that if a room's quite shallow, then actually windows on one wall are fine. But if it has a very low ceiling, then you need to have windows on more than two walls, and this kind of pattern generates nice spaces. So in the fitness calculation, I look at the floor area of the room and I look at the amount of external wall, and it scores it appropriately. So as you can see with this building, it has an awful lot of external wall for the rooms, but that's completely tunable. Another pattern is this 6-foot balcony pattern that we saw, and then there's all various patterns about circulation, about how close living rooms and kitchens should be front doors, and how far away bathrooms and bedrooms should be, and so on, and they're all implemented as well. So we were asking about sloping terrain. So this model here, in fact, I'm going to turn off cycles for this. As you can see, that's actually these are all at different heights. So that this site, if you look at that elevation, so this site climbs by I don't know, 6 to 7 meters from one end to the other. But that's all in the defined. So so it's defined in the plot. So I tell each plot what elevation to build the house at, and those elevations don't really affect anything apart from the daylight. So obviously, if buildings higher up, then they're taller and they cut out more daylight from surrounding buildings. So as you can see, this model here is quite a steep site.
So did you actually cap it at a certain number of floors, or is that something that naturally came out of the daylight?
Yeah, so no, actually, no. This is one of Alexander's patterns. So he has a 4-story limit on his patterns. So he's quite strict about that. He says that if a building has more than 4 stories, then it's no fun climbing upstairs, and you shouldn't build them. I'm personally, I'm not quite strict about these things, but I feel that because this book's existed for 35 years and that nobody's ever been building his buildings to his rules, that I should be, at least for now, I should be quite strict about this stuff. So yes, it'll quite happily design a 5-story building, and the evolution will produce them, but the fitness calculation will say, this is a 4-story building, and it will knock down the score. Sorry, it's a 5-story building, and it will reduce the score. There are other things, because I'm programming the floor area ratio. That would also reduce the score. Because a very, very tall building on a small site would have a very large floor area, and that in its own right would trigger one of the patterns, one of the fitness calculations. Any more? I think I might have a. Any more questions? We probably have some other business to talk about. Okay, no. Yeah, I've been talking for an hour now. So is there anything else that anyone would like to talk about, or anything else?
So one last quick question. So where do you see taking this further? Just implementing more patterns, or?
So there are various bugs. You can see some of these. There's some like here, like there's a. If you go in that door, there's a staircase in the way. I have to fix things like that, and that's actually a stupid bug, because the doors and the stairs are all quite well organized elsewhere in the model. So there are a whole load of little bugs that are going to take up some time. Where do I want to take it? I want to design some buildings at some point. Initially. It'd be quite fun to do some proposals, some counter proposals for some building schemes. So if somebody proposes a development that I don't like, I might propose an alternative scheme, and that would be a good way of developing the software and trying it out a bit more. Another use for it, which actually might be a bit more, because I've been in some discussions, is actually building holiday parks. But in some ways this is quite appropriate for designing like a Center Parks type holiday resort. So that might be interesting. You should play with that. So I don't know where it's going to go. Obviously, at the moment, I don't have any business model for this, and none of it's been paid for by actually producing any real designs for real buildings. So it'll go wherever it gets taken, I guess. How are we going? Cyril was asking a question. Is that my web browser? I'm using Firefox, so maybe I shouldn't be using Firefox.
No, I was talking about someone which seems to be disconnected often, not you.
Yeah. Okay, thanks. I'm glad it's working, because my internet can be quite flaky. So I'm glad we've got this far without disconnecting.
It's very cool. I'm very impressed. Great work.
Yeah, thanks. There's so many more directions I can take. you know, but there's time. I mean, the moment, I mean, your the Blender BIM has been great. It's actually been allowed me to really work on the IFC output, which has improved enormously in the last few months. But at some point I'll stop doing that and go back into fixing bugs and in the design process. And I'd like to do some more styles. You know, I'm getting a bit bored of this style with all these porches and Georgian windows. Of course, the stylings is also, the buildings are skinnable, so I could apply the courtyard skins to these buildings, and they might look a bit strange, but you know, that's how so creating new skins would be quite good fun. I might do some more of them.
Bruno, you mentioned before that for a post and beam system, this is not, let's say, applicable, but this has to do just with the code, let's say. This could be something that could be extended.
If you're building a post and beam, so a post and beam structure you tend to work more on a grid. So if you look at the corners of these buildings, yeah, all the junctions between walls are all generally T sections. They don't have to be, but they are. Yeah. So if you see these walls here, it's a T sections junction. Whereas if you're building with post and beam, that's actually really quite awkward, because you would need to have two columns at quite close together to support these walls here, yeah, or this corner. So if you look at traditional Japanese buildings, there are very few of these T junction wall junctions, and lot more X-shaped wall junctions. And I think that if you wanted to do a system that designed Japanese houses, you might not choose this binary tree model. It's very much applicable to load-bearing wall construction.
Okay.
Yeah, so I've still got a section cut in here. I don't know where. Yeah, so it's not cutting all these buildings. That's interesting.
They were added after the section cut.
Yeah, so I've imported 2 IFC files in it, and it's not coping. Yeah.
Correct. You need to remove and then re-add the section plane.
Yeah. Okay. Yeah. Let's see if that crashes.
Oh, I see. You're not meant to delete. You're meant to press the remove button. That would probably cause a crash. I know. It's terrible, isn't it?
There you go. Yeah. Okay.
Yeah.
Yeah. All right. Yeah. So we'll find something. Learn something every day. Now, I saw there was an agenda. We have those other items that people wanted to talk about. Or maybe I've used up too much time.
No. You took exactly as much time as you needed, and that was important.
Okay, great.
I'm looking at the agenda. There's 4 items here. There's the Blender BIM logo. Don't really know what to say on that one. I think it's going on well. We'll continue to wait for any submissions. And if it's been a month and no new more submissions, I think we'll just call a vote and tweak it, do some final tweaking and until we're happy, and that's it.
Okay.
Unless somebody has other ideas. Next one on the agenda is the pros and cons of different modeling paradigms. So these are things like solid modeling, which I guess there's solid, and then there's constructive solid geometry. There's NURBS and meshes and B-reps, and I guess some of the more exotic ones like point clouds and voxels and even metaballs in Blender. Duncan's not here, and that's quite a big topic in itself, and I'm not sure who is most qualified to talk about it all, because each one of those is kind of a specialty. So that's probably good to be delayed. Introduction to IFC. So why IFC, introduction to IFC OpenShell, and the different implementations and goals for IFC support. That's a big topic as well, so maybe that's good for the next session. It's not really a 10-minute thing. And then a quick preview of FreeCAD's experimental tools. That's Carlos work over here. So if that's a quick one, it'll be good to show it now. If you feel as though it needs a bit more time, we can delay until the next one as well. We can bump that up to the main agenda.
Well, I feel quite embarrassed to show something really at the beginning of the development process after this presentation by Bruno. But if you want, I don't think I will take more than 5 minutes, really.
Go for it.
Okay. So I apologize for my English, that's not so good. And also for my programming skills, because that's really the first thing that I'm writing in my life, probably. But I wanted to show you because I started to get quite addicted to FreeCAD and to the FreeCAD forum in the last year and a half, let's say. And in the last lockdown period, I had quite a bit of fun playing with the Beam Workbench. And well, I didn't feel so comfortable with some of the tools that were in the Beam Workbench, so and there was always a big talk going on about the assembly workbench in FreeCAD, so the possibility to assembly things, mainly for the mechanical design. So I was thinking about writing some really basic tools to emulate what the FreeCAD did for the mechanical assembly and port it to the Beam Workbench. And so together with Yorick, we introduced these really easy, simple tools, a wall and an opening window at the moment. So I just wanted to show them to make you aware that this work existed and was carried on. So maybe you can criticize it and give some ideas to improve it, or just well, say your opinion and collect some ideas on how it can be improved. So, well, there's nothing more than a wall, a tool to join corners, join a wall, a tool to T-join a wall, and an opening object that is a bit of an opening, a void, or a door, or a window. And, well, something really easy. You can just draw a wall, like you did before in the Beam Workbench. And then you have the possibility to join two walls with a corner joint, for example. And these are keeps knowing that one wall is joined to the other, and they are separated objects, not as it was used to do in Beam. So when you move a wall, FreeCAD automatically recomputes the position of the connected walls. Same it should do. Okay, probably there are a lot of bugs, so maybe something will not exactly work during the presentation, but I didn't test it before too much, so it's what's mainly developed to quickly be able to create a model and to modify it. Then the other tool is an opening tool that is goes nested to the wall object, so you can still move the wall object and the opening moves a bit. You can tweak it a bit, make it bigger. And what changes mainly from the model paradigm of the Beam workbench used before is that objects generates its own local coordinate system. So you always know that the wall center is located on the X axis of the wall, and the opening is located on the X-axis of the wall. And also the opening generates a local coordinate system that is located at the middle center of the opening. So you see the opening position Y and Z is always 0 because it's located on the wall axis. This makes quite easy to nest other objects inside the windows. What we try to do at the beginning is that, okay, so for example, if you place a window and the window is located on the wrong side of the wall, you can just change it and you quickly change on the other side. And also the opening object is an object that you can nest other objects into, or you can use some default subcomponents. So for example, you can place a seal object and get a seal object, or the filling type can be rectangular. Okay, this will not work, so we won't try them now. Or you can change the number of panes, 2 to 3, whatever you want. Change the pane thickness, millimeters. I don't know if it worked. Yes, I think it worked. Yeah. I didn't have to change that. Okay. And what else? Oh, you can place a door. It's really basic at the moment. I just wanted to show a bit of how you can play with it. Also, you can place another wall inside and key-join the wall instead of corner join it. And then you should be able to move it and it still fix to the other walls. And let's say you can do it in direction, I don't know. How do you do that? Okay. And of course, like the other objects of the Beam workbench, you can change the height, or you can just subtract some other objects. Or, I don't know, make some sloping roofs. So you can subtract the extrusion, and you can perhaps change the sketch. I don't know. So you change the subtraction, and you still keep everything parametrical linked together, so you can move it. Okay, and the last thing I wanted to show you is something that I was experimenting. I wanted to be, since the first day I started playing with Picard, that is a section plane object that works exactly as an actual section plane, but the only difference is that this object is able to contain other objects. So, for example, if we, I don't know, we move it just a little bit higher, okay, then we can activate it, and it brings us to a plane, to a kind of 3D drawings, but in fact this is just a section cut of the object that holds its working plane position. So, for example, we can, I didn't have to do that. Yeah, maybe. It's not working exactly as it should, but that's really highly experimental. You can add more objects that will be kept together with a section plane, and then you can deactivate it We go back to the other model, and all the objects that are inside will just disappear until next time we'll activate it again, and you will find them again. So you can put, for example, a dimension, deactivate the section plane, and you hide everything contained in the 2D view. Okay, that's all for the moment. Really nothing more. If you have any question or something that, or perhaps you want to try it and to report back in the forum, because I'd really like to know the impressions of the users on that.
It's very cool. I like it.
Thank you. Well, we are working also on some other stuff, but because, for example, from the, I think, next release of FreeCAD, it will be possible to, let me see. Okay, but I should open another fork of FreeCAD. Anyway, you will be able to have some path objects and to make some links to them. Link is this new, really cool object Real Thunder developed. But I just push this part. So you can link many objects that are just the same object in scene and be able to change some dimensions. So this should allow to support IFC types better. And so the opening object that we are developing should be able to embed different kind of windows. And some windows you should be able to design them with, for example, the path design workbench, as you can draw a mechanical part of the object of the project. So you can integrate some tools for the architectural modeling together with some tool for mechanical modeling. And this should bring, in my idea, the BIM arc workbench of CAD more near to the mechanical part of the software, because the tools they use now are a bit separated from the mechanical parts. If we can keep them together, I think both the architectural workflow and the mechanical workflow can develop faster in just one direction. That is this direction of a kind of assembly modeling. So you can design something, but mainly put things together and build a building made of several components. Some of them you build them by your own, and some of them you just find in Productor's libraries. You can just develop, download them and put in your model and embed into some objects that are thought to be able to embed ready-made components. Yeah, that's all.
Just a question, to try this, what you are developing, we have to reinstall the BIM workbench. How does it work?
Yeah. Yes, you have to download the FreeCAD 0.19, one of the most recent builds, possibly, but you can find them in the Git. So I should use Python. So let's go to the FreeCAD. Okay, and then we go to release page. You get one of the build 0.19 pre, one that fits with your operating system, and then you install the BIM workbench. You will find this toolbar with the communist red stars on the tools. And these tools, okay, don't use them for production because they are really experimental and full of bugs. So please report everything, and we will try to fix it as soon as we can.
Okay, thank you.
You're welcome. So please, I'd be really glad if everybody wants to try them and report back in the forum or write to me how you feel with them.
Thanks, Carlo.
You're welcome.
Yeah, there's a lot of compliments in the chat. Huge improvement for the workflow, good progression there. And agree, huge UX improvement.
What?
Okay, if there are no more topics for this one, maybe we'll wrap it up. It's good to have a shorter recording than 2 hours, as we've done in the past. There was a quick one on the forum. I think maybe 2 weeks ago, there was a short demo of BlenderBIM's work in progress features, and there'll be another one in 2 weeks' time. And that's just for showcasing the latest buggy stuff in BlenderBIM add-on. And the recordings have been put up in case you want to watch them. And this recording will also be put up as well. And unless anybody else has anything else to say, I guess we'll wrap up this monthly meetup and meet again for the next one. Thanks again, Bruno. That was an incredible talk.
Yeah, thanks for bearing with me. Thanks. It's good to be able to describe these things. Yeah.
Thank you, Bruno and Carlo. We saw some amazing stuff today. Really, very nice.
Yeah. Yeah. Okay, great.
Okay.
Okay. Thank you. Goodbye then.
All right.
So, see you
all. Bye-bye.
Yeah. Bye.
Okay, bye. Okay.